Right. So the routing protocols are more friendly than static route. If you take the routing protocol, there are various type of routing protocol, and the names are also different. For example, there is a type called distance vector. Distance vector. There is another type called link state. There is another type called path vector. Now, distance vector, there are two protocols. Routing information protocol and enhanced interior gateway routing protocol. This both comes under type called distance vector. Likewise, link state also there are two protocols. Open shortest path first. Intermediate system to intermediate system. And for path vector, there is only one protocol called BGP. Earlier, we had another protocol called EGP. Now it's no more.
Okay.
So no more EGP. It's only BGP. And this BGP is again two flavors. One is IBGP. Another one is EBGP. So we are going to see in this program, this is CCNA level. So we are going to see RIP, EIGRP, OSPF, and BGP also to an extent. Again, OSPF not completed. We are just going to touch the CCNA level of OSPF, which is more than sufficient for a data center. See, when you are working on data center, you are not going to do ISP level of OSPF tuning. You will not have an opportunity to do that. In data center, you will not have that need. Other than enabling OSPF, you will not have a big level of tuning like you have in a service provider track. In data center. So whatever is necessary for a data center, we are going to focus. So in data center, you will find RIP, you will find EIGRP, you will find OSPF. And BGP very rare. But we will also see BGP to an extent here. Now, why do we need these many protocols? Why is these many number of protocols? Any idea? Why these many protocols? But routing protocol is to provide route. Why these many protocols? Do you have any answer?
Basically about our requirements vary.
Correct. No. Transport is the same. You want to go from one place to another. But you have bus, you have car, you have motorbike. Likewise. Depending on the requirement, you will pick one. You will not go in a bus to drop your kid in school. You may have a bus, but you will not go in a bus. You will just take one bike or a car to drop your child in school, because the road is going to be fully compact, because every parents want to bring their children. If you will take a big car, then problem for you. You will go in a bike. No, that's how I do. I don't want to go in a car to drop my children because the road is narrow and there's a lot of parents with the road. So I take a bike. Likewise. Even in the networks, there are different requirements. Some networks
Mm,
don't have enough amount of bandwidth. In
mhm,
such places, we should not use protocol like RIP, because RIP is going to
mhm,
consume some bandwidth every 30 seconds.
mhm,
Periodically, RIP will send update.
mhm,
I cannot use that RIP. So what I'm just trying to say is, depending on your need, you will pick one protocol. For that, you should know
mhm.
about these protocols. Only when you know about these protocols, you will know which protocol to use for your requirement, for your
Requirement, yeah.
environment. That's why we need to learn all of this. None of this is
Yeah.
bad. All the protocols are good. All the protocols are
Mhm,
important. Some people used to say,
mhm,
RIP, it's a small protocol, it's an old protocol. No, that's not true. Every
mhm,
protocol is important. Depending on your need, the importance level may vary. The preference level
mhm.
may vary. But when I say preference level, I need to say something like administrative distance.
Mhm.
Administrative.
Distance. Okay.
Every protocol is important, I
Mm.
told you. But
Yeah.
Cisco has given
Mhm,
some default importance level.
mhm,
Small number more important, okay? Small number
mhm,
more important. For
mhm,
EIGRP, Cisco
mhm.
says 90.
Okay.
For OSPF, Cisco says
Mhm,
110.
mhm,
For ISIS,
mhm,
it's 150.
mhm,
For RIP, it's 120.
mhm,
For
mhm,
EBGP, 20. For IBGP, 200. I told you, smaller is preferred.
okay. Preferred,
Smaller
yeah.
is more preferred.
Mhm.
Smaller is more
Okay.
weightage. Now, what about the static route that you learned?
Mhm,
Static route, if you're going to give an exit
mhm.
interface, I told you static routes, you can do two things. One, you can give exit
Yeah.
interface, or you can give next
Yes.
router's
Correct.
address,
Correct.
isn't it? If you are using exit interface for static
Mhm,
route, then it is 0.
mhm,
Administrative distance is
mhm,
0. If you are going to give next
mhm,
hop address for
mhm,
static route, it is 1.
mhm.
Now you see, what is more
Static,
trusted?
static, with more
Static is
trusted, yeah.
more trusted. In that, directly connected is more trusted because you are giving your own exit
Mhm.
interface.
Got it.
Next hop address may change sometime. You may not trust. But this will
Mhm,
never change. That's connected to your device,
mhm,
isn't it? So, this numbers that they have given in
mhm.
Cisco is just for
Okay.
default. But most of the people, they keep it without changing.
Mhm,
See, this is just to have one number they have given. You need not to keep all this number.
mhm,
You know what I have done in my few
mhm,
deployments in
mhm,
Nigeria. I have given static
mhm,
route administrative
mhm.
distance of 210.
Oh.
I did not
Mhm.
give this. I gave 210. You know why?
Because of that.
For
Yeah.
me, I want static route to be used only if all the routing protocol
Mhm,
fails. When I give
mhm,
210, Will the static route be in the routing table if OSPF gives
No.
route? No. If OSPF gives route, static route will not come. If no protocol gives the route, only then static route that I wrote will come into the
Yes,
routing
yes.
table. So I always go with customized administrative distance. I don't go with default. I go with customized. Yeah. So administrative distance is the numerical value using which you tell your router which one to give more important. Should I give static route or OSPF or RIP? If all the routing protocols are enabled, which one should I give more importance? Is by giving the number. Smaller the number, more importance is given. But it is good to know these
Yeah.
defaults because I know the default IBGP is 200. I gave 210 in my production for static route. If I don't know this 200, I will not be able to give the 210,
Yeah, correct.
isn't it? So better know these numbers. That is default. Again, I want to give you a warning. Warning, warning, warning. These numbers are not universal. This is
Cisco specific,
Cisco.
right? Okay.
Cisco's default. The other vendors may have different number. For example, Juniper has got 25 for OSPF. I think for static route they have 5. Okay, so even in Juniper, I'm telling you, don't leave it default. Just go and change the number according to your need. You don't need to rely on this number. You can very well change for any routing. Okay. So one thing I have very clearly said that administrative distance are changeable. What you see is default.
Sir, yeah.
Second thing what I
One
said
question.
is
Yeah.
it is not same for every vendor.
Yeah, yeah.
Let
One
me
question. So basically, for example, if I enabled OSPF and ISIS protocol together on Cisco switch, then they have identified the route towards a specific destination. So they have both routes. So in
no. Both may be giving the route
yeah,
to you, your router, but your router will install only the
OSPF,
OSPF route into the routing
got it.
table. ISIS route will be there in the database, but it won't come to the routing table.
Okay.
The one with the lower administrative distance only will come to the routing table.
Okay.
Okay. So, two things. One is this is default only for
Yeah.
Cisco. Juniper have got another default values. Huawei has got different number for Huawei as default. So you need to know before you configure. If you're configuring Juniper, go to Google or go to Juniper and check what default they have. So that you can go and change according to your requirement. Okay. So what is administrative distance? It's the preference.
Yeah.
It's the importance that you give. Right. Now, we are learning this first protocol written for routing information.
Sir, one question like there is a protocol called SSRP, right? Is it important for data center?
It is not routing protocol.
Oh, okay, okay.
We'll talk about SSRP later. That is not routing protocol.
Okay.
Okay. Now, you said HSRP. What it is? It is redundancy protocol, hot standby, redundancy protocol. It's not routing protocol.
Understood.
This R is not routing.
Okay.
It is redundancy protocol. This comes under a topic called first hop redundancy protocol, FHRP. FHRP, one of the FHRP protocol is HSRP. The other one is VRRP. And the other one, which is not at all popular, which is GLB. Virtual hot standby routing protocol, virtual route redundancy protocol, gateway load balancing protocol. Again, these are all not routing protocols. They are redundant protocols.
Okay.
They are a first hop redundancy protocol.
Got you. Yeah.
Now, RIP stands for Routing Information Protocol, which is distance vector protocol. What is distance vector protocol? Distance, you know what is distance? How far?
Correct.
Correct. How far? Let's say I'm in Dubai. I'm in Dubai. Now, here is India. Here is Qatar. Here is Oman. Here is Saudi. Now, if I am in Dubai, to go to India, I should say 4,000 kilometers in this direction.
Direction. Okay.
That is what vector. Direction. 300 kilometers in this direction. Abu Dhabi. 60 kilometers in this direction. 400 kilometers in this direction is Oman. You know, so you need to also tell the direction, which is very important, with the kilometers. If someone says, how far is India? 4,000 kilometers. If they don't say the direction, then you will be going like this, 4,000 kilometers. Will you go India? No. You may be in Sudan. So, distance alone is not enough. You also need to know which interface I should exit from the router. Yeah? Which interface I should exit and how far. How far means what? How long distance? What is the distance? Okay. So, in RIP, the distance is measured in hop count. Hop count helps to measure the distance. We call this metric. Metric of protocol RIP is hop count. Type is distance vector. Now, there is a limit for the protocol RIP. What is the limit? The limit is 15 hops. Is the valid metric. It's only between 1 to 15. It's only 1 to 15. 15 hops. What is hop? You see?
2 hops, yeah.
1, 2 hop. This is 2 hop. For going from A to J,
2.
I need to go 1 and 2 hop. Likewise, 15 is the maximum hop RIP
After that, it won't then
learn routes. It won't learn. See, from the J is learned from 2 hop away.
1 hop.
K is learned from how many hop away? Just 1 hop. 1 hop. Likewise, Rip can learn routes only from 15 hop. From the 16th hop, when the update comes, this router will not accept because it is considered as infinite. 16 is an unreachable metric. Unreachable metric. 16 is an unreachable metric, infinite metric. So about metric, we have seen 3 things. Metric is nothing but distance in which the remote network is measured. The remote network here in our example J, K, they're all remote networks. To reach that network, hop count is what RIP uses to
Measure,
measure. See, we say 4,000 kilometers.
Yes.
So we measure using kilometers. 1 kilometer is 1,000 meters. 1,000 meter is how many centimeters? Whatever, we don't want those things. What I'm trying to say is, we measure in kilometers. But in the aeroplane, they don't measure in kilometers. They say nautical mile. They don't say kilometer. They say nautical mile. They have different measure. So every routing protocol have got different way measuring the distance. RIP is using hop count as a metric.
Yeah.
Not every protocol will use the same. Now, if I ask you how far is Dubai, you may say, hey, it's not too far, man. It's very near. How we are saying that? Because the time taken is only 4 hours, 50 minutes or 30 minutes. It's only 4 hours, 30 minutes. Man, it's not too far. But if someone asks, how far is to go to Delhi in bus, you'll say, no, it's too far. For Dubai, you said it's very near. But for Delhi, you are saying it's too far. Why? Because I said in bus. In bus, Delhi is too far. Even though the aeroplane time taken is only 1 hour, 30 minutes. 2 hours. It depends on the flight, how high it is going to fly. No, it's 2.5 hours. Really. So, even though the kilometer is less, if someone changes the transport, for Delhi they are asking bus. Which one you want to go? You want to go to Delhi or you want to go to Dubai? For Delhi you have only bus.
Right.
For Dubai you have flight. Which one you will choose? You will choose only the flight because the number of hours taken is less. See, for you, you are using a number of hours as a metric. But if your friend picks the destination, if your friend decides he will go to Delhi, why? He don't have that big money to take a Emirates flight. For bus, if he pays like 1,000 rupees, he can go to Delhi. Assume. But aeroplane is going to take 25,000 minimum Emirates. So for him, metric is not number of hours. For him,
Money,
the metric is money. See, for everyone, it's not the same, no? For some, money is the metric. For some, how long it is going to take is the metric. For some, how luxury it is going to be my travel. They want to see how luxury. They pick that one. So, likewise. Every protocol have got their own way of deciding the metric. RIP is using hop count. But
Okay.
not every protocol is going to use hop count. EIGRP will use bandwidth and delay. OSPF is going to use cost based on bandwidth. ISIS is going to have fixed cost. BGP is going to have attributes. They all have different reason to say this is best and that is worst. So, in simple, what I want to say here is the routing protocols, they don't have same way of measuring the distance. RIP measures using
Path,
how
yes.
many routers in the path. If I have two routers in the path,
Yes.
then it is two hop. But EIGRP will not see
Got
the
it.
hop; it will see the bandwidth. For example, I have another path here. This is 10 meg. This is 1 gig. This is 1 gig. If I enable RIP and EIGRP,
Because
RIP will say
only
this
one
is the
hope.
best path. Why? Only one hop. But EIGRP will say, no, this is the best hop, best path. Why? Because it's 1 gig more bandwidth. If the road is big, I can zoom like this. But here it is too narrow. I need to go very slow, pressing a lot of brake and accelerator, brake, accelerator, clutch. Takes time. So, every protocol has got their own style. Depending on what you want in your network, you can go with that. If I want in my network hop count to be considered as a metric, I'll go with RIP.
Yeah.
Isn't it? So, metric of RIP is hop count. And the infinite metric is 16. So, you should have all the routers within 15 hops.
Correct. Yeah.
In order to have a RIP, you cannot have more than 15 hops.
Which means like if we so in our network topology we should have only 15 routers, right? Is that mean?
Yeah, you can say like that. See, if you have less than 15 router, and if you want hop count to be your metric, you can go with RIP. But you know where RIP is really used? Wherever VPN is. I'll show you an example. Now you see, I'm going to form a tunnel between this router and this router. Now from A to B, if you want to go through the tunnel, see, what is tunnel? Tunnel is a virtual connection. VPN, virtual private network. It's a virtual, why? It's not physical. This tunnel is going to use this physical path. Now, which bandwidth will be more? Tunnel bandwidth or physical link bandwidth?
Tunnel.
How it is possible?
Correct.
Tunnel is going to use a physical link. Now, whose bandwidth
Physical.
will be more?
Yeah.
Physical link bandwidth will be more. Now you see, when I enable OSPF, will OSPF take this path? No.
Yes.
Why? OSPF focus on bandwidth.
Okay.
OSP will say, I'll go this way. I'll go hop by hop. But if I enable RIP, RIP will not use bandwidth. RIP will see hop count. RIP will say to reach B, I'll go like this. Even the tunnel is established using this path, end of the day the packet is going to go like this only. But Packet get encapsulated here and get
Sir,
decapsulated
it's
here,
the same. I
not
mean, in
here.
VXLAN, I saw like this topology uh, where OSPF we are configuring. So, is this the reason we are configuring OSPF for VXLAN kind of topology? That's a different. Okay, sure.
No, that is different story.
Mm-hmm.
That's a different. Now, I'm telling you why I need RIP. If I
Okay.
enable RIP, I can go via tunnel
Mm-hmm.
because RIP won't focus on bandwidth. RIP
Mm-hmm.
will see how many
Mm-hmm.
hop. Just one hop, I can go to B. But if I go this way, it is
Mm-hmm.
1, 2, 3, 4 hop.
Mm-hmm. Yeah.
RIP will use the upper path. You got it? All right. So
Mm.
every protocol is important. The RIP is important
Yeah.
wherever we have this type of tunnel based. Okay.
Mm-hmm.
So we have seen here the metric and administrative distance of RIP. The default administrative distance
Mm-hmm. Yeah.
is
Mm-hmm. Yes.
120. Yeah? Yeah, I told you, no, earlier.
120.
The
Yeah.
top, if you see, I told you. RIP default
Mm-hmm.
is 120. And it is a distance vector protocol. Metric is hop count. Now, RIP has got periodic update. The RIP will not learn
Mm-hmm.
neighbor. RIP will not form any neighbor. RIP will send update
Mm-hmm.
periodically to everyone to make sure the routes are still
Okay.
valid. Now, how often the updates are sent? 30 seconds.
Mm-hmm.
And if a router did not say update for 180 seconds,
Mm-hmm. Okay.
then it is considered to be possibly down.
Mm-hmm.
And in the 240th
Mm-hmm.
second, the route will be removed from the routing table.
Mm-hmm.
The route will be completely
Mm-hmm.
removed from the routing table only after 240 seconds.
Correct.
See, every 30-second update should come.
Mm-hmm.
If it is not coming, the counter will keep increasing. Even up to
Mm-hmm.
179th second, it will think
Mm-hmm.
that the route still exists. The route might have already gone down. But
So
the
packet loss
routlet
will
which
happen, no?
received the route, they still think that it is still available.
Mm-hmm.
And
Mm-hmm.
that's the bad part of it. Again, you can tune these things.
Mm-hmm.
Now, after 180 second, it considers possibly down,
Mm-hmm.
and in another 60 second, which is
Mm-hmm.
240, it removes the route from the routing table. So totally how
Got it. Yeah.
many minutes? It takes 4 minutes.
Mm-hmm.
For
It
a route that is
will
gone
remove.
down,
Mm-hmm.
only after 4 minutes it will remove. Till that time,
Mm-hmm.
first 3 minutes the packet will be simply sent and dropped. Okay, so that's about the timers. Next, Reaper's got two versions. Version 1 is a classful version. What is that? If you have
Mm-hmm.
subnetted network, they cannot handle. Why?
Mm-hmm.
Classful network, they don't advertise, do not advertise
Mm-hmm.
subnet mask. So if someone has
Mm-hmm.
subnetted, how
Got it.
you will know whether it is /16 or /24? So subnetted network,
Mm-hmm.
if you have in your environment,
Okay.
you should not go with version 1. You should go with version 2.
Mm-hmm. Yeah.
Version 2 is classless. Alright? Version 2 is classless. Alright? So we'll stop here.